Hi, hello everyone, welcome back to my channel. This is Lekana. Today I am here with a new topic, that is Introduction to Data Structures. In this video, we're gonna learn what is data structures and why we need data structures, types of data structures. First, what is data structures? A data structure is a particular way of organizing data in a computer so that it can be used effectively. The idea is to reduce the space and the time complexities of different tasks. Example for data structures. Data can be anything that can be saved. It could be a primitive type or a non-primitive type. In the primitive we have strings, boolean, integer or floats. In the non-primitive types we have arrays, linked lists, trees, stacks and queues. Next, why we need data structures. Data structures provides an easy way of organizing, retrieving, managing and storing data. Here is a list of needs for data. A data structure's modification is easy. It requires less time. Save storage memory space. Data representation is easy. Easy access to the large database. Next, we have types of data structures. Data structures are divided into two parts. One is primitive data structures and one more is non-primitive data structures. Examples for the primitive data structures are int, char, float, double. And for non-primitive data structures, these are further divided into two parts, that is linear and non-linear. In non-linear, in the linear we have array, stack, queue, linked list. In the non-linear we have tree and graph. Next, we have primitive data structures. Primitive data structure is a data structure that can hold a single value in a specific location. The examples of primitive data structures are float, character, integer, and pointer. The value to the primitive data structure is provided by the programmer. The following are the four primitive data structures: integer, float, boolean, character. The integer data type contains a numeric values. It contains the whole number that can be either negative or positive. When the range of integer data type is not large enough, then in that case we can use a long data type. The float is a data type that can hold decimal values. When the precision of decimal values increases, then the double data type is used. Next we have boolean. Boolean is also a one more data type that can hold either a true or a false. It mainly used for checking the conditions. And one more we have character. Character is a data type that can hold a single character value, both uppercase and the lowercase, such as a capital A or a small a. Non-primitive data structure. The non-primitive data structure is a kind of data structure that can hold multiple values either in a contiguous or random location. The non-primitive data types are defined by the programmer. The non-primitive data structure is further classified into two categories. One is linear and the non-linear data structures. In case of linear data structure, the data is stored in a sequence, that is, one data after another data. When we access the data from the linear data structure, we just need to start from one place and we'll find another data in the sequence. These are the examples for the linear data structures. We have arrays, linked lists, stacks, queues and strings. First, we'll discuss about an array. An array is a linear data structure and it is a collection of items stored at a contiguous memory location. You can see the image. This is how we declare an array. This 0, 1, 2, 3, this is we called as an indexes. These are the memory locations. The idea is to store multiple items of a same type together in a one place. In array, we can store only a same data type. We can't store any different data types. We can store only, this is the main drawback in this array, we can't store a different data types. The first element of an array is indexed by the subscript of 0. It begins with the 0 index. And there are different operations which will be performing on an array. They are the searching, sorting, inserting, traversing and reversing and deleting operations are done in this array. Next we have linked list. A linked list is a linear data structure in which elements are not stored at contiguous memory location. The elements in a linked list are linked using pointers as shown in the below figure. You can see this head. This is nothing but this is a pointer for this linked list. These are called as a nodes. This is one node, this is second node, this is third, and so on. This first is data, and this is a link. This is linked to the another node. There are some types of linked lists are there. They are singly linked list, doubly linked list, circular linked list, and doubly circular linked list. Next we have stack. Stack is another linked linear data structure that follows a particular order in which the operations are performed. The order is FIFO. FIFO in the sense last in, first out. Entering and retrieving the data is possible from only one end. The entering and retrieving of data is also called push and pop operations in a stack. There are different operations possible in a stack, like reversing a stack using recursion, sorting, deleting, and the middle elements of the stack. You can see the elements. This is called as a top. This is a push operation. Push in the sense inserting a variables, and the pop deleting the variables. Next we have queue. Queue is also a linear data structure that follows a particular order in which the operations are performed. The order is FIFO. This is first in, first out. The data element stored first will be accessed first. Which data elements are stored first? They will be accessed first. In this, entering and retrieving